Good morning and welcome everybody. I'd like to thank you guys for joining us this morning to talk about the Markforged technology. Today we're gonna do a basic overview of the Markforged technology and really kind of dive into what is so special about the Markforged technology. What does Markforged have to offer to help you that can help you in your daily tasks? Okay. So let's dive into the Markforged technology, what it is, and how it works. So first we call it CFF, Continuous Fiber Fabrication, otherwise known as FDM. We just can't call it FDM because somebody out there has the patent on that acronym. The way this technology works is our base material is a nylon 6. So it's a nylon 6 material that is filled with a chopped carbon fiber. And we call that material an onyx. And the way this works is we lay this down layer by layer via the extrusion through a heated nozzle. Now, what's significant with the Markforged technology is we have the ability through a secondary nozzle in the same print head to extrude a continuous fiber in a carbon fiber, Kevlar, or fiberglass. Now, what this allows us to do is add strength in certain areas of the part or the entire part to gain extra strength in this part. So, what is so special about Markforged? Well, the reality is that's the material. It really is a combination of the hardware with the material, but the hardware was developed around the material. So let's talk again about the material. As I mentioned earlier, our Onyx material, which is our base material, is a nylon base material. It's a nylon 6, and it's filled with chopped carbon fiber. So right off the spool, this material, even if you don't use any secondary reinforcement, is significantly stronger than ABS. In fact, it beats ABS in just about every category. But when we go back to what's special, it's the secondary reinforcement of our material. Again, we can do this with a carbon fiber, Kevlar, fiberglass, or high strength, high temp fiberglass, all as a continuous strand that we inlay into our part layer by layer. Guys, understand, we are printing parts in plastic material that are stronger than aluminum. So I know everybody's going, yeah, plastic parts stronger than aluminum. Yeah, right. Well, let's look at this stress strain curve. So if we start at the bottom of this, we see our tough nylon, which is just a straight nylon 6 for comparison. And then right above that, we see the stress strain curve on ABS. When we see that compared to Onyx, we clearly see that Onyx is above ABS. But when we take that Onyx material and we lay a continuous strand of Kevlar in there, look at the significant jump that we see. Even in fiberglass, we're getting up there up there in that Kevlar range as well. Now, I want you to notice, here's our stress strain curve on a 6061 T6 aluminum. Now, if we lay carbon fiber into this part, look at where we are. The proof is here, right? Also, I want you to take a look at the graphic here. This graphic here on the right-hand side, this shows a layer. So what's happened is we've laid the Onyx material down, which happens first, and then the secondary process is it has laid a continuous strand of Kevlar in there, and that's what a layer would look like with the Kevlar impregnated into that layer. So let's jump over and take a quick look at Onyx versus the ABS material. So if we look at all these categories, heat resistance, stiffness, strength, and toughness, even if you pay no attention to the numbers in these charts, you can see that Onyx wins every time, and not by just a little bit. We kill ABS every single time. So let's talk about pain points. I walk into lots of businesses every day who are trying their hand at desktop 3D printing, your filament style 3D printing. And the common pain points that I hear from my customers, and I may have been in some of you guys' facilities even and had these conversations. So the common ones are, my 3D printed parts off these machines are weak and they break. Can't hit tolerances with a desktop machine. They've got terrible surface finish and surface quality. Have a super low heat deflection temperature. And then last but most important is, I can't print fixtures with this desktop machine because the materials won't survive cutting fluids. Now, with the Markforged technology, we address every single one of these with our super tough parts, down to 50 micron layers so we can hit our tolerances. Great surface finish. If you look at the graphic there on the right at 50 micron layers, that's a super smooth part. We have a pretty high heat deflection temperature, so we're up at 140 C. And then 3D printed parts surviving the cutting fluids. Well, this material being a nylon 6, it's extremely chemical resistant. So we have lots and lots of customers now that are direct printing all of their machine tool fixtures, their part holding fixtures, soft jaws, end arm tooling, stuff like that. And that brings us to the most popular applications. So the most popular application for the Markforged technology, hands down, is the jigs, fixtures, and tooling. We're beginning to see machine shops put farms of the Markforged machines in their shops that do nothing other than to produce tooling for machining parts, holding parts, inspection fixtures, along with assembly fixtures, all your subtractive tooling. And the reality is, this is because this is a nylon-based material, so not only are we chemical resistant and we can survive the cutting fluids, nylon is as well abrasion resistant. So you have the abrasion resistance for repetitive use. The next one is end-use parts. Obviously, in a low-volume production situation, we do have plenty of customers out there that are producing the end-use parts on these machines due to, again, the tough characteristics of the material. Prototypes, obviously, everybody knows that 3D printing prototypes is a big application. Again, this kind of fits into the jigs, fixtures, and tooling and automation. There's a really big push in automation as far as end-arm tooling, lots of custom tooling for robots. If you have a robot, you want to be very dynamic with the robot and be able to handle multiple product lines. So if you have the ability to just print your end-arm tooling or any other robot-associated tooling, makes you very dynamic in your manufacturing there. And then automotive, I mentioned earlier, our heat deflection of 140. In particular combinations, we're seeing a heat deflection as high as 150 C. And then education. Education is buying lots of Markforged machines, and the significance to us in the industry is that we've got the kids that are coming right out of school now that are graduating with the experience with the Markforged technology, and they understand how to apply that, and so that can do nothing but help your business. Next, let's take a look at the machines themselves. There's two distinct categories in the Markforged Composite line. There's the desktop in the industrial category. The desktop having a build volume of 12.5 by 5 by 6 and a max resolution of 100 micron layers compares to the industrial at a 13 by 10.5 by 8 build area, which will go down to a 50 micron layer. But what we have at the industrial level is what's called in-process laser inspection. And the way that this works is that there is a built-in laser scanner in the print head. And we define, when we set up the part in the software, what layer we want to inspect. We can inspect as many or as few layers as you want. So once we define that layer, when the machine completes that layer, it's going to use that laser scanner in the head to scan an image of the actual geometry on the build plate. And it's going to lay that layer right into the CAD model that you brought into the slicer software. At this point, you have measurement tools where you have the ability to go in and analyze your geometry to ensure that your part is growing within tolerance. What this allows you is the intelligence on the fly to understand if your part is building out of tolerance, that you can understand what's going on. So you can either stop it or allow it to continue. And what this gains is both time and material savings. So if you have an extremely large build going on and you realize that it is building out of tolerance, you have the ability to stop it, saving that time, and then as well as material that you would use that would end up being wasted material if the part was growing out of tolerance. So a question I get a lot is, hey Kyle, what's it take to maintain one of these Markforged composite printers? You know, it prints this fantastic material, but surely it's difficult to maintain. And the reality is, it's not. This is one of the simplest machines in the 3D printing world to take care of. You would inspect belts after each print. You're just going to look at them, make sure they're still tight, and then after approximately 60 prints, you want to do a retention. Retention procedures are very simple. We've got them up on our website. They're up on the Markforged website. It's a really simple process. Takes about 10 or 15 minutes. Don't have to do it all that often. Changing the nozzle out. So as you begin to see parts grow out of tolerance, you're typically going to want to change that print nozzle out. Those things are going to last anywhere from 30 to 100 parts, depending upon obviously the size and geometry of your part. The next and final thing, I know it seems really obvious, but we always have to say it. Keep the machine clean. You know, keep the debris out of the machine. Keep the screws and all the leads nice and lubricated. And other than that, these machines will run for many, many years to come. So that leads us into the warranty. So the factory warranty on a Markforged machine is 90 days. So for the first 90 days of ownership of your machine, everything is covered. That's a bumper-to-bumper warranty. Obviously, you get MLC support when you buy that machine from us. If you've got problems, you call us. We're going to help you out, whether that be a print problem or a mechanical problem. All success plans. And what these are, this is an extended warranty. We offer these in 1, 3, and 5-year increments. And what this covers is everything. It's a bumper-to-bumper warranty. It's service, it's support, anything that you need associated with your Markforged machine. The only thing that this is going to exclude is acts of nature and vandalism. Now let's talk about consumables, which is obviously the price of your part. So the base material of Onyx, $189 a spool. This is 800 cubic centimeters. And then as we look at the prices of our fiber down here, you can see that depending upon the type of fiber that you use and how much of it that you use, it's going to affect the price of your part drastically. So you can have a part that goes from $3 to $30 pretty quickly depending upon the reinforcement that you use. Typically, the round number that we use with a adequate amount of reinforcement is about $5 a cubic inch to print a tough Onyx part with reinforcement. Let's talk about the Markforged slicer, known as Eiger. The universal language for 3D printing is an STL file. So you're going to do your design work in SolidWorks or your CAD package of choice, and you're going to save that as an STL file. Then you're going to import that into Eiger, which is the slicer. Now you have no CAD tools in a slicer other than a scale. So you could take apart and print it double size, half size, something like that. Now Eiger it's an extremely simple, clean interface. It's a cloud slicer, so it runs right in Google Chrome. It's extremely secure. It's accessible from anywhere. As well, lets you monitor your machines, so you can get statistics off your machines. We have the ability to print out trends per user, per material, stuff like that. And then we have multiple versions of Eiger. The most popular version is the cloud version. This is standard. It's free, comes with the machine. You can put as many users inside of this as you need. We also have a local storage version. So for those people that aren't comfortable with the files sitting on the cloud, we can set this up where it stores all your files local and the software is still just in the cloud. So that keeps your files all local. And we have an on-premise site for those people building the next generation stealth fighter. This is going to be a dark site. It does not require any type of internet access. It's loaded once. It only gets updated once a year. You lose all communication with the machine as far as statistics and stuff like that goes. So you have to really need this to use this version. And there is there's cost implications to a dark site license. All right, let's take a look at Eiger, and we're going to use this soft jaw part as an example. So if we look over here at the box on the left-hand side, it's going to give us the statistics that we need to know about our part. It's going to tell us our print time, material cost, and our total plastic volume. So this is important because it's going to tell you what your part's going to cost. For your particular application, you may be looking for a specific cost per part, whatever that may be. Now, this updates dynamically as we change the properties of this part. So for example, if we were to add carbon fiber to this part, we're going to hit save to update. Now remember, this is a cloud-based software. So what it's doing is it's pushing all the changes that you just made up to the cloud, and it's going to modify each and every layer. So before it didn't have any fiber, now we're adding fiber to certain layers that we allocated. So what it's doing is it's writing the path to add that fiber to those layers. So it's going to go in and write that path all the way around the part. So if you say you wanted 4 loops at 100 layers, it's going to write that path, and it's literally going to write the G code in the background for your machine to follow. So as you hit print, it's going to send this program down to your machine exactly how you want it. Now, as this thing updates, we're going to look at the box here on the left for our soft jaw part and see what our price and our time came up to. Okay, so we added a few hours to our print time because we added more actions, right? We added fiber to this thing. It's going to take longer for sure. And then look at our material cost. It essentially doubled. And that's because we added the most expensive fiber that we could, and we added quite a bit of it, you know, as far as the carbon fiber goes. So let's take a look at that fiber inlay. So let's switch over to our internal view. And everything you see here in blue is your fiber that has been inlaid into the part. So in this particular case, I think I'd like to add some more up here. So the easy way to do that is just to come right in here, and we're going to drag this over to achieve what we're looking for. So notice here on the left, our estimated print time and our material cost is going to adjust as we drag these around. So we're going to say we'd like a little bit more, so we're going to pull this just a little bit more over here. And again, so we're dynamically adjusting over here as far as estimated print time and your material cost. So I think I like that. So we're kind of taking what's called a sandwich panel mentality here, and this would be the same mentality that they use in building the panels in which they construct aircraft with. Very strong, still very effective. It actually does oftentimes is just as strong as a part that's completely full of fiber. So just great FYI. All right, so we're going to save that. We like those updates. Let's go back to our part. Looks good. From this point, we're really ready to print. So we could hit print, and when we hit print, we come to our next layout. This is where we would add either multiple parts or other parts, and then we can just drag these things around. So let's say we need 4 of these. We're going to click on it 4 times, creates 4, and here we are, we're ready to go. So we just drag these, we can drag these anywhere we want. And at this point, we can either export the build or we can send it to our machine. So we can send it out here and hit print, and what it's going to do is say it's going to uses a lot of fiber, so we're going to hit print anyway. So we're going to add to queue. That machine's busy at this moment, so it's just going to add it into the print queue. So it's the next job in the print queue. So when we do that, it's going to go out again. It's going to push this whole job up to the cloud, and then my machine's sitting on Wi-Fi, so it's checking all the time. So once this job hits the cloud, the machine recognizes that it has a job, and it pulls it down, puts it in the queue. So for now, let's go back and let's look at some other aspects of Eiger while this thing's going. This is what your library would look like. You have all your parts here saved. Click them, view them, whatever you need to do. When you need to reorientate a part after it comes in, all you have to do is click on a face. It's going to move that thing around wherever you want it. When a part turns red, it doesn't fit into the print volume. Pretty simple, you need to twist it around or something like that. Alright, so remember we talked about statistics. We can go over here and we have a dashboard. It's going to tell us jobs per week. We can do that per user. We can look at printer bandwidth, so how much your printer is being used. We can also look at, hey, I'm buying a lot of material and not seeing a whole bunch of parts. What's going on? Where's my material going? So we can look at all of that. We can export all this data to a CSV file, all that kind of good stuff. About Eiger before we move on to metal would be the fact that Eiger will run all Markforged products. So let's take a look at this part real quick just for an example. So when I say all products, that means the desktop machines, the industrial machines, both of those being in composite, as well as metal. So we can set our metal parts up right in the exact same software that we use for our composite printers. And in fact, you could switch back and forth. For example, this part's set up for a desktop machine, but all we have to do is change it to a metal. We would change the material once those materials become available. We're going to cover all that here in just a minute. Currently, the only material available is 17.4 stainless, and when we hit save, it's going to go out and it's going to modify this part. So it's going to change it from a composite setup to a metal setup, and all in the same software. It's going to give us our print time and our material cost. So we went from composite to metal right there on the same screen. Now, let's talk about metal. So I saved the best for last, yeah. Let me introduce to you the Metal X. The Metal X is a new twist on an old technology. This machine has a build volume of approximately 12 by 9 by 7 with a 50 micron layer height. And the process is called ADAM, Atomic Diffusion Additive Manufacturing. So when I said this is a new twist on an old technology, all we're doing is we're extruding a filament that's filled with powdered metal through a heated extruder, just like we do our composites. So it's a three-step process where we're going to extrude that part out onto the build bed of our machine, and then the part's going to come out of our Metal X printer. It's going to go into the wash. And what happens in the wash is this is a debinding. So we're going to melt that plastic binder that held all that metal powder together. We're going to melt the vast majority of that out of that part. And that part's going to come out of the wash. And it's going to go into a sintering oven. And it gets sintered through the recipe that is sent to the sintering oven from Eiger. So you don't have to have a metallurgist on staff or anything crazy like that to figure out how long your part needs to be washed and how long your part needs to be sintered. Eiger software does all that for you, figures out all of the shrink between the printing and the sintering process so that your part comes out true to CAD. Now, our material yield is a 99.7% dense material. So your material coming out is going to be equivalent to that of billet material. Important to note, this is not a laser sintering process. Now, like I mentioned, the equipment, there's a couple different sintering options. Obviously, we have the Metal X, we have the wash station, and then we have two sintering options. We have Center 1, which will support up to 2 Metal X machines, and then we have a Sintering 2 that will support up to 5 metal machines. And what this does is this allows you to ramp up metal production. So as you're producing parts on your Metal X and sintering those, you could be mass producing parts right here, just like this. Now, requirements. Nothing too crazy. The Metal X has an optional ventilation. It is not required. It's there in case you need it. Wash 1 does require exterior ventilation along with the sintering. This is imperative. You must have this. Requirements a 4-inch duct with 100 cubic CFM capability. Now, your sintering oven must be hardwired by an electrician prior to us arriving to install your machine. We will show up with a gas supply panel. You will need argon and forming gas there on site for us to hook up to your machine. All right, let's talk about material. So like I mentioned earlier, the current launch material is 17.4. So all Metal X machines are shipping with 17.4. Now, it has been indicated to us that around the end of the year, by Q4, we're going to be adding these beta materials. I have seen parts in these materials. They do exist. They are very close to being released, and therefore they will no longer be in this beta material list. Those include 316 stainless, A2 tool steel, D2 tool steel, 6061 aluminum, 7075 aluminum, Inconel, and titanium. I think everybody's waiting on that titanium release. Okay, here's some mechanical data. This is going to show us a stress strain curve along with their mechanical properties. So what we've compared here is a part that was printed, goes through the debinding process and the sintering process in the Markforged products. This process being identical almost to the metal injection mold process. We've actually compared this as well to a part printed on the Markforged Metal X and then sent out to a production metal injection mold facility for that part to be processed. And as we look at those two stress strain curves, those are eerily similar, very, very, very close. So the point in this is that we're creating those parts just like at an industrial metal injection mold factory. We as well compared that to just a straight piece of wrought iron 17.4 stainless that was purchased from McMaster. You see that curve, slightly better properties, but it's a little different process. So what everybody wants to know, how much is it? So the turnkey solution for a Metal X is going to run you right around $150,000. So this is a drastic difference from what we've known for 3D printing metal options. So traditionally in a laser sintering option, it's going to cost you $400,000 to $500,000 just to step into the game, and 9 out of 10, $750,000 to $1 million. You know, really depending upon your options. So this is quite an affordable technology. It's a great place to get your feet wet into the metal and take the next step. So let's talk about consumables and how these parts actually print. So our consumables are this that we see. We've been told that the price of consumables are going up the end of this month, so you guys need to go ahead and buy your machines and get lots of consumables at this price because they're going to go up about $30 to $40 a kg. Now, the way this prints, if we look at this graphic here, this is a part printed in this technology. Now your supports are a 17.4, but what it does is it prints what we call it's a ceramic support material between the actual support and the part. And what happens in the sintering process is this ceramic material literally turns to powder, and your support just pushes out or falls off of the part when the sintering process is complete. So with that, the team for 3D printing here in the state of Texas would be myself. Here's my contact information. You can also reach out to Amelia Parada, and then Travis Bates. Travis is our service guy, so he's going to come out and do the installation of your machine. If you have any problems, he's going to help you out, and if you need any type of repair, he's going to come out on site and get that thing done.